Hello everyone. So in this tutorial today we are going to learn about the red blood cell. Red blood cell is also known as the red blood corpuscle. Corpuscle means just an particle which is suspended and flowing into the fluid. Whereas erythrocytes, we also call it the erythrocytes, which means erythro is red in color and kytos in Greek word is called as the hollow vessel. So it carries oxygen and hemoglobin, and that is why it is called as a red hollow vessel, and that meant to the erythro, that is kytos, and nowadays cyte is also known as like to the cells in Latin word. So we have different shape. Let us talk about the shape of the RBC. So RBC has got a spherical shape if we see it in front, from the front, and if we see it from the side we can see it as in dumbbell shape. So dumbbell shape means the periphery is around 2 micron thick, whereas center is of around 1 micron thick, whereas the diameter of this red blood cell is around 7.2 micron, and it has it is consisting of the central pallor, which is 1/3 of diameter of this RBC, and this size of RBC is nearly equal to the size of nucleus of lymphocytes. So what is the benefit of this shape actually? So this shape is given by, or it is due to the spectrin protein, which is also known as the contractile protein of the RBC, which gives it this shape, which makes the or maintain the shape membrane like this. So what is the benefit then? So the major benefit is that it helps in diffusion of oxygen into the cell. The advantage of biconcave shape means there is advantage, and that advantage is diffusion of oxygen into the cell, or else also H2O is diffused very rapidly. There is large surface area due to this folding, due to this biconcavity, and which also helps in absorption and removal of substances. Whereas this shape helps our RBC to squeeze out of the capillaries very efficiently without damaging itself and providing the tissue the required oxygen and nutrients. And now also minimal tension on the membrane. Due to this shape there is minimal tension on the surface. Suppose if anything is like entering in the RBC, so this shape try to maintain the integrity of the RBC. So this is giving by the minimal tension on the membrane. So this is about the shape. So if there is abnormal shape in RBC, there are unusual shape. So usually the unusual shape can be seen in RBC, and that is known as the poikilocytosis. Poikilocytosis means RBC could be of teardrop cell or flask shaped, or let us say as pencil cells, we can call it, as a shape appears like that. In different anemias we can see that. Similarly, we have an isocytosis, which talks about the size of the RBC, like unusual size of the RBC. So unusual size means that might be of different sizes, and usually we see most common thing either microcyte, that is smaller than this normal size, whereas macrocyte, larger than this normal size. So this is about the variations in size and shape. Now let us talk about the count of the RBC. So normal count of RBC is around 5 millions per cubic mm of blood in male, whereas 4.5 millions per cubic mm of blood in female. Female consists of slightly less RBC, and we will see it in ongoing duration. So this is, now we can call it, if there is like a normal count, then there must be increased count or decreased count. So in increased count, the condition is called as the polycythemia, whereas a decreased count we can call it anemia, that is reduced effective circulating red blood cell mass, and that is called as anemia. So what is the condition? So polycythemia is the increased consistent count of the RBC in our circulation, and that might be pathological as well as physiological. So let us talk about the physiological polycythemia at first. So we can see, as in infant, there is increased number of RBC, we say, and it can cause and rupture after 10 days, causing physiological jaundice. So what is what is the reason behind it? There is less developed spleen as spleen is considered as the graveyard of RBC. So there is less developed, so there is less degradation of RBC during infancy period. Anyways, moving forward, we have in gender 1, we can say that male consists of the higher count of the RBC because of the testosterone, and like androgen and testosterone helps in like production of or like helping in the stimulation of erythrocyte synthesis or production, and that is lacked in female. That is why there is less count in female. Similarly, due to the increased altitude, we can see, and this physiological polycythemia is usually temporary and just marginal. A slight elevation is seen, which is not permanent, which can like recede to normal after some certain duration. So in increased altitude means there is decreased pressure. So decreased barometric pressure means there might be the condition of hypoxia in our blood or body, which will be sensed by kidney, and kidney sensing the hypoxia will release the chemical erythropoietin, and that erythropoietin will further stimulate the bone marrow cell. That bone marrow cell will again produce erythrocytes, and in that way there is slight increase in the person living in altitude, that is nearly around, let us say, 7 millions per cubic mm, or we can say that they are adapted to live in that count. That's why there is increased physiological number of RBC, count of RBC. So exercise and emotion. This exercise and emotion can stimulate the sympathetic nervous system. Sympathetic nervous system is stimulated, release the adrenaline from the adrenal medulla, and that will cause the contraction of spleen, and that will release the stored RBC into the circulation, in a way increasing the condition, that is blood number count, that is RBC count in our blood. Similarly, in exercise, for an expert or trained athlete, due to the hypoxic condition in the like exercise during the muscle, like during exercise in the muscles, it will produce or help in the stimulation of production of erythropoietin, and that will be like maintaining a kind of steady level of the increased RBC count in trained athletes. So that is how in physiological conditions there is increased number of count in RBC, and that is called as polycythemia. Similarly, in pathological we have the primary one and secondary one. So primary means malignancy due to the bone marrow, it causes the polycythemia vera. So this is not much to learn, we will learn it in different topic as well, very separately. Then we have the other like different conditions such as respiratory diseases, congenital heart diseases, right, and there might be like carbon monoxide poisoning condition. Similarly, we have also the condition of hepatocellular or renal cell carcinoma, which might release erythropoietin, and that might increase the count. So these are all the conditions that might lead to the increase in RBC count secondary increase in RBC count, that is known as the pathological polycythemia. Then okay, then we saw about the increased count. Now let us see about the decreased RBC count due to the physiological condition. Pathological conditions are numerous, such as anemia. Anemia is caused either due to the hemolysis, or there are different like deficiencies that might cause it. The genetical condition may cause it. So let us see physiologically. So after sleep, usually different systems of our body is like reduced, like different systems is like shut down, and that is why also there is less production of RBC. Similarly, during the pregnancy, due to the increase in plasma volume or ECF volume, the hemodilution occurs, and that is relative decrease in RBC count. That is called as relative decrease in RBC count. That will lead to the like kind of anemia, but that is temporary again. So high barometric pressure, like this pressure means there is high oxygen tension in our blood. So there is enough oxygen in blood, so that might somehow marginally lead to the reduced RBC count. So that is how there is reduced physiological RBC count in our body. So this is all about the red blood cells, and this is a very general information. In our next tutorial, this is the first part of this, and we will learn about the site and production and factors affecting this synthesis of RBC in next tutorial. For any queries, do comment below. Thank you so much. See you again, and bye bye.